Today I'm talking to Erich Hoyt about his new book, Planktonia, in honor of World Plankton Day. He is a whale and dolphin researcher, conservationist, a lecturer, and author of 26 books. Thanks so much for joining me today, Erich Hoyt. So, what is plankton, anyways?
Well, it can be a plant or an animal, first of all. So plankton is called phytoplankton, and the animal plankton is called zooplankton or zooplankton. And really, it's not a group of species. It's really just anything that can't swim against the current. Even some fish that can't swim very well, are considered plankton. I think if you threw a human in the water who couldn't swim, you could almost call them plankton because they wouldn't be able to go against the waves. So it's got a broad definition.
Cool. Some are scary looking, like octopus. Some, like the thorny seahorse, are adorable, and lots, like the lion's mane, are really beautiful. Which one's your favorite?
I like these slipper lobsters and the shrimp that like to catch a ride, on the top of a jellyfish on the bell or the medusa. But it's not just catching a ride. They use them for defense. And some of these little, juvenile lobsters, they're like kids, can be seen clutching a fish in both of their arms, and they're like swords in a way. And they could just kind of keep everybody off by, I'll just dangle these jellyfish tentacles in your way. So I think that's pretty cool.
Yeah. Mine is the immortal jellyfish because when it's frightened, it can turn back into like a baby.
Into a polyp. That's
Yeah,
right.
start like life
Yeah.
all over again.
Yeah, and start all over again. Yeah, I wish we could do that sometimes.
It says in your book, keeping oceans healthy starts with phytoplankton. Why is plankton so important?
Well, it's, 50% of the oxygen that we breathe comes from this phytoplankton. So, we really couldn't live without it. But it's also the basis of all life in the ocean. Even blue whales, that are the largest creatures, depend on krill, and the krill eats phytoplankton. So without phytoplankton, we wouldn't have whales, we wouldn't have anything in the ocean really, and we wouldn't have ourselves because we depend on it. And the earth would be in a lot of trouble.
Yeah. How do they absorb carbon and how much do they absorb?
It's through photosynthesis that the phytoplankton consume carbon dioxide, and it's like forests or other land plants, that can take in carbon. And the phytoplankton are really responsible for most of that transfer of carbon dioxide from the atmosphere to the ocean. And they consume that carbon dioxide during the photosynthesis, and then the carbon gets incorporated in them, and then the carbon stored there. And that's actually a really important point for climate change because they do a big job in terms of helping us by all the carbon that they absorb. Then when phytoplankton gets eaten by other zooplankton and then gets eaten by whales, all that carbon just keeps flowing through the system. And then a whale dies, goes to the bottom of the sea. That's where the carbon goes. So there's a really important process happening there that's vital for climate change and the climate emergency that we're all in right now.
Yeah. So basically, it gets stored in the bottom of the ocean?
Yeah, when anything dies, it goes to the bottom and becomes part of the sediment and bottom, creatures like sea cucumbers and other creatures that are crawling around on the bottom consume some of it, but it stays down there, and it's in that way it's not a danger to us.
Yeah.
It's not heating, making the earth get warmer.
Yeah. How is climate change affecting plankton and what does it mean for our planet?
Well, at the same time, that's a good question. At the same time, climate change is also, well, it's heating the ocean, which makes it more difficult for plankton to live there, phytoplankton and zooplankton. And it's also with the waters rising in the ocean, which is as a result of climate change, that makes it more difficult. The conditions become more difficult for phytoplankton to live. So we're seeing some of that breakdown in certain areas of the ocean, but we have a good chance to do a lot more right now. Maybe this is our last chance over the next 5 or 10 years. I really think we need to get it together, and it's partly your generation that's going to be saddled with this if we don't get it together soon.
Yeah. The coolest thing I read in your book is that they can be a 40th size of a red blood cell to the size of an Irish wolfhound. What do you think the coolest thing about them is?
Well, actually, I love the fact that most of the zooplankton are larval stages, they're juveniles, and that they have these flamboyant fins, all flashy colors and all these trailing lines coming off of them, and that make them look like dangerous jellyfish, or they try to fool other fish, so that they don't know, if they're coming after them, they don't know exactly where they are. And in fact, this is the cool thing, is that when they're juveniles, when they're zooplankton, only about this big, they have a separate evolution with different evolutionary pressures on them, different from when they're adults. So, this is kind of unusual with species to have a completely different evolution. And so the evolution that allows them to survive when they're underwater and they're tiny and trying to come up every night to the surface is something that makes them they have to look a little bit dangerous to other animals. They have to mimic, things that other animals would stay away from, predators. So I think that's pretty cool, and some of these zooplankton have, 5 or 10 stages that they go through when they keep changing. I mean, we know with butterflies, they go from caterpillars to butterflies, but, this is 10 stages. It's really, really complicated.
The one thing I love about the book is that it has so many pictures of all the plankton.
Oh, yeah. Yeah. Yeah, and most of those, you couldn't have taken those pictures even a few years ago. It's photographers now are going out at night into the open ocean with very sharp cameras that can take sharp pictures of very small plankton that are moving all the time. So they have to freeze the motion. So there's a lot of skill involved, and it was fascinating to talk to them and look through thousands and thousands of photos to come up with the ones for the book.
Yeah, and one of my favorite pictures is here's the immortal jellyfish.
Oh yeah,
Really
mysterious and
yeah. One of my favorite pictures in the book is this one here.
Oh yeah, with all the jellies around. Yeah.
Because I don't know how they just glow like that.
Yeah. Well, that's the bioluminescence. I like to call it the language of light, because they talk to each other with light. Some of them flash on and off, and they have all sorts of signals that can mean all kinds of things. We don't know most of it, of course.
Yeah. What can kids do to help protect oceans and plankton?
I think in your own life, obviously recycling, keeping track of your carbon emissions and try to keep them low, talk to your parents.
Yeah.
But I also think studying hard to become scientists, educators, teachers, politicians, and just knowledgeable citizens to make a difference. So which people in government can make the biggest changes that'll help everybody, but also starting it from your own personal life, and what you can do. I think all of that is important. And get out there, get into the ocean, walk along the beaches, pick up anything you see. But meanwhile, have a look at, there's a lot of interesting stuff there. When we look out at the ocean, we see the surface. We can just imagine what's going on down below. But, with a face mask, you can start to appreciate a lot of the stuff going on down below. And that's part of it. That's why I wanted to do Planktonia, partly to show people, this is some of the stuff that's going on all around you.
Yeah. There are a billion phytoplankton in the world's oceans, more than there are stars in the sky. What do you wish more people knew about plankton?
Well, I love the great vertical migration and the idea that these tiny larvae and juvenile of the fish and invertebrates that can't swim very well, yet twice every night they lurch up to the surface, some of them from quite deep. You know, how they manage to do that. I mean, I've seen them just kind of, some of them have one or two appendages, and they'll kind of push up, but it's so difficult. You know, I mean, these are not swimmers, so not great swimmers, but they get up to the surface every night for feeding and to, you know, hang out with other zooplankton. And then as the night goes on and it gets toward morning, they go back down. So that requires an enormous amount of swimming, even though they're not swimmers. You know, and we talk about whales and albatrosses and sharks and all these other animals with long horizontal migrations, you know, that go across the earth and across oceans. But really, in the numbers, as you said, billions and billions and billions, and the frequency of, you know, going up and down, I think we can say the greatest migration on our planet comes from these tiny little creatures, the plankton, that are moving up and down vertically every night.
Yeah. And sometimes when fishermen go fishing with like those giant nets, plankton get caught in like the nets and their fins break, so it's harder for them because they're
Yeah,
like so delicate.
yeah,
Their fins like
yeah.
fall.
And that's why they, you know, scientists didn't know very much about them until recently with these photographs, because when they pull collecting nets, you know, to try and learn about them, they destroy them in the process. So, yeah.
Thanks so much for joining me today. And remember,
Well,
together kids can save the world. Please like and subscribe. Thank you.
oh, thank you, Robert. It was a pleasure. Good
Thank
luck.
you. Thank you.
Yeah. Cheers. Bye for now.